Okay, today we are going to learn chapter 4, which is Kanaf map method. This is the outline of chapter 4. In chapter 4, we are going to see how to simplify an equation with 2 variables up to 4 variables using Kanaf map. And we are going also to learn how to design the combinational circuit. And also we are going to see about the expression X in Kanaf map. Okay, in previous chapter, just to recall back, we have learned how to simplify mathematical equations using Boolean algebra's theorem and De Morgan's theorem. But now, in chapter 4, I will show you how to simplify mathematical equations without applying Boolean algebra's theorem and De Morgan's theorem, but by using Kanaf map or simply K-map. So what is actually K-map? K-map is one of the easiest ways to simplify Boolean expressions. It is a graphical representation of the output of a given Boolean expression. K-map actually contains the same information as a truth table. The practical usefulness of K-map is limited to 6 variables. And in our syllabus, we are going to discuss problems only up to 4 variables only. Okay, now let's try to see in details about K-map. So this is K-map. Okay. K-map contains a cell for each input combination. On your left, you can see a 2-input truth table. Okay, 2 input because you have only A and B. A Boolean expression or a truth table with n input variables has 2 to the power of n cells on the K-map. So try to recall back what have we learned in chapter 2. In chapter 2, I told you if you have 2 inputs, you're going to have 4 possible output. Okay, so here if we want to transform this truth table into a K-map, you are going to have 4 cells because you have 2 inputs and 4 outputs. So the number of cells should be the same with your possible outputs. So if you have 4 outputs, you are going to have 4 cells in your K-map. So this is known as 2-variable K-map. Why 2-variable? Because you have A and B. So in this K-map, when you transform this truth table into a K-map, instead of just having A and B, you are going to add A bar and B bar. And you can see small number for each cell here. Start with 0, 2, 1, 3. What does this number represent? Okay. A bar represent value 0 for A. A represent value 1 for A. Similarly, for B, B bar represent value 0 for B. B represent value 1 for B. Okay. Now, try to see this cell. Okay. This cell belongs to A bar and B bar. Okay. So, meaning that A bar A0, B bar B0. So 0, 0. 0, 0 belongs to row 0. So that's why we write 0 here. Okay, next. Let's check why do we write 2 here because A1, B bar, B0. A1, B0. A1, B0 belongs to row 2. That's why we write 2 here. Next, this cell belongs to A, the intersection A and B. So A1, B1. A1, B1 belongs to row 3. So we write 3 here. Okay, similarly, for this one, A bar intersect with B. So A0, B1. A0, B1. So belongs to row 1. So that's why you have number 1 here. So that's how you transform a truth table into a K-map. K-map cells are labeled so that horizontally adjacent cells differ only in one variable. As you can see, in this figure, the first cell starts with A bar and the adjacent cell is A. That is if we consider horizontally. If we consider vertically, the first cell starts with B bar and the next adjacent cell is B. Okay. Similarly, vertically adjacent cells differ only in one variable. This is what I mean just now. Okay, next. Let's try to see how to transform a 3-variable truth table into a K-map. In this truth table, we have 3 variables, A, B, C. So if we have 3 variables, we are going to have 8 possible output here, which is 2 to the power of 3 equal to 8. So when you have 8 possible outputs, you are going to have 8 cells for your K-map. So starting with A bar, B bar, then followed by the next cell differ only one variable, A bar dot B, followed by another adjacent cell, which is differ only one variable, A dot B, and then last one, A dot B bar. That is if we consider horizontally. If we consider vertically, it will start with C bar followed by C. And then, similarly, we have small numbers here. And if you see carefully, the number is not in a proper arrangement. You might be wondering why the number is 0, 1, 2, 3, 6, 7, then 4, 5. It is not properly arranged here, right? But let's try to check whether the value is correct or not. Okay, let's try to check the cell with number 3. The cell with number 3 belongs to the intersection of A bar dot B and C. A bar means A0, B1, C1. So 0, 1, 1. So check your truth table. 0, 1, 1 belongs to row 3. So it is correct if we write 3 here. Now let's try to check this cell, cell number 6, whether it is correct or not. Okay, this is the intersection of A dot B and C bar. So A1, B1, C bar, C0. So 1, 1, 0. 1, 1, 0. The value belongs to row number 6. So it's correct. Okay, last one. We try to check this cell with number 5 inside. Okay, we check the intersection A dot B bar, then C. So A1, B0, C1. So 1, 0, 1. Okay, where is 101? 101. So it belongs to row number 5. So it's correct. Okay, that is the explanation why the number is not in the proper arrangement. Okay, that is a K-map for 3 variables. Next, let's try to see a K-map with 4 variables. Okay, on your left, you have a 4 variable truth table. You have A, B, C, D. So if you have 4 variables, you are going to have 2 to the power of 4 possible outputs. So your row will start from 0 up to 15. So similarly, for your K-map, you are going to have 16 cells. 16 cells numbered from 0 up to the maximum is 15. And once again, if you see the number inside each cell, it is not in a proper order. Okay, 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. So the explanation is same as before. Okay, but before that, let's try to check the arrangement for the variables for variable K-map. So we start with A bar dot B bar. The adjacent cell is A bar dot B. Okay, differ only one variable. The next cell, A dot B, followed by the last one, A dot B bar. That is if we write horizontally. If we write vertically, it will start with C bar dot D bar. The next cell, the cell below it, will differ only one variable only. It will follow with C bar, then dot D. Okay, next C dot D, and then next C dot D bar. Okay, let's try to check whether the number inside each cell is correctly written. Okay, let's try with this one first. Cell number 15. Cell number 15 is actually the intersection between A dot B and C dot D. So A1, B1, C1, D1. So 1, 1, 1, 1. So belongs to row number 15. So it's correct. Now let's say we try to check cell number 9. Cell number 9 is actually the intersection between A dot B bar and C bar dot D. So meaning that A1, B0, C0, D1, 1001. 1001 belongs to row number 9. So it is correct. Okay, so that's how we transform from truth table into K-map. So we have seen how to transform 2 variables, 3 variables, and 4 variables truth table into K